welcome back. In the previous video, we have seen what is strict partitioning, what is dynamic partitioning to allot the memory to any process. Now we see another method that is called segmentation, how the memory is allotted here. So what happened, we have read till now is that there will be a process which has a virtual address space and this is mapping to a physical memory. Okay, so suppose this is 0 to 16, so 0 to 16 is mapping to 32 to 48 directly. Okay, but in segmentation the whole virtual address space is not mapped directly, but we know that this virtual space address space has a three different components. What are these? Code and data, heap and stack. Okay, now what will happen in segmentation, rather than mapping all this on a single place, we map it into three different locations. What? We can map code to here. Okay, now heap to here. Okay, now stack to here. Okay, so we use three base and bound register rather than using one. In segmentation we have to use three because we have to map all the three into three different places rather than mapping at one places. We map code here in the physical memory, heap here and stack here, and we can calculate the mapping physical address with the help of base plus offset. So how we know the base and offset? You can know the base of a physical address space to where it is mapping through example like here the base start at 32, here the base start at suppose 34 and here the base start at 42. So the base of code is 32, heap is 34 and stack is 42, and we know and we can select the bound is 2 KB, now suppose 4 KB and 2 KB. Okay, now offset here is suppose you wanted the value of 1 KB of code. So how will you do? The code of base is 32 plus 1, 33. Okay, so for heap suppose you start from 2 to 6 and you wanted 4, so what will you do? Heap 34 plus 2, 36 KB. But in stack grow upward from 12 to 10 and here it grow from 42 to 40. So here the offset value will be negative rather than will be positive. So here it will be 42 minus 1, 41. I hope you will be clear from it. But you asked one very good question, that if the virtually address space only send offset value, how will we know this offset value is for code or heap or stack? How will we know? If offset value said 1, how will you know it is for code, heap or stack? So for this we always send a 14-bit address from 0 to 12 is for offset. Okay, offset, and 12 to 14 for identification. So suppose code can be given 00, heap can be given 01, stack can be given 11. So what will happen? If you wanted to send offset of 1 to code, so you will write 00 to identify for code, and now you write 12-bit offset value of heap. Suppose you wanted to send a offset value of 1 to heap, so you will write the same for offset, but here you will write 01, so that the physical memory or OS can know that it is for stack, code or heap. I hope you are now clear. Now suppose the offset value here come more than the bound value. Here Here you see that bound value is 2, 4 and 2. Now suppose the offset value will become 5. So what will happen? The OS will give segmentation error. What the error it will give? Segmentation error. I hope now you will be clear about the segmentation error. Now we will see one more important concept of segmentation, that is called code sharing. What is code sharing? And with the help of protection bit. Suppose this is your memory, physical memory, and you have two process, okay. Both process have a same code, okay. So how will you memory allocate it? Code for process 1, stack for process 2, 1, heap for process 1, similarly code for process 2, heap for process 2 and stack for process 2. Here if the code of both the process is same, so why we are allotted two different times? We can allot only one code for both the processes, okay. That is called code sharing, okay. But here there will be one big issue, that is if there will be a two process 2 come and change the code, so process 1 also have get the change code. So to protect this, we use the protection bin, and this protection bin give the protection to the code that you are only allowed to use read method on that code, not write method. With the help of protection code, you can only read on that code, not any process does not allow to write anything on code or change any code. They can only do read method, only they can read the code. So if you have two processes which have the same code, you can use protection bit. OS use the protection bit to protect the code from only writing them, and with this protection they can use this code on the sharing basis and save the space for one code. I hope you will be now clear about what is code sharing with help of protection bit. Now there will be one more concept in the segmentation, that is called external fragmentation. Okay, fragmentation. So what will happen to external fragmentation in segmentation? Do you suppose it will get not present? I think not so. Why? Suppose this is your physical memory, okay. You have OS here, you have code here, you have free memory of 5 KB here, you have heap here, you have 5 KB of free memory here, you have stack here, and you have 10 KB of free memory here. And now suppose in a second process come which needs 15 KB. Can you allow to this segmentation physical memory? No, because there will be a no 15 KB continuous block. So in segmentation there will be a external fragmentation also present, but no internal fragmentation is present. No, and there will be high multi-programming degree of multi-programming increase in segmentation. There will be no internal fragmentation because there will be no wastage of memory here. The memory is only allotted to the required thing. If the code requires 10 KB, then only 10 KB is allotted, not more than it. So internal fragmentation is not present, but external fragmentation is present, because if any process which require more than the chunk pieces, that cannot be allotted. So external fragmentation is present in segmentation, but internal is not present. You can do code sharing with help of protection bit, okay. You can use two identification code so that the physical memory can know that this offset value is for code, stack or heap, okay. And how the offset value is calculated, I hope you are now clear. Offset value is always negative for stack because it is growing upward, and code and heap is growing downward. So you have to choose the negative offset value here. And segmentation, I hope now everything is clear to you. We will meet in the next upcoming video. Till then, goodbye.